24 is, and the number that appeared there is 3. That means our median is 3. Question C has asked for standard deviation, which has the abbreviation of SD. And I've told you we calculate it by summation D, FD squared. I don't know why I always want to write D first. But even if you have D here and F here, they are the same thing. But most authors have it like this, divided by summation F. That is your standard deviation when you find the square root. Okay, we are going to create a sub-table, just like we did here to calculate the mean. We are going to create a sub-table where we are going to extract the values we substitute for our standard deviation. So the table is going to take this form. Let's have x, then frequency, maybe the mean, before the deviation. You know that deviation x minus m. The number minus the mean will give you the deviation. Then the next thing we need there will be our d. So this is our d, then our d squared. And then fd squared. Fd squared. Whatever we get in this column, we add it together. It will give us summation fd squared. Okay, let's divide it into a table. Our x is these numbers 1, 2, 3, 4, 5. So we have 1, 2, 3, 4, 5. The frequencies attached to them are 6, 10, 6, 10, 24, 15, 6. Now our mean, we calculated the mean to be 3. Yes, 3. So let's have 3, 3, 3, 3, 3. So let's divide out this. To form the table. Okay, now our x minus m, which will give us the d, is 1 minus 3. 1 minus 3, which will give us minus 2. In this case, it is 2 minus 3, which will give us minus 1. In this case, it is 3 minus 3, which will give us 0. In this case, 4 minus 3, which will give us 1. In this case, 5 minus 3, which will give us 2. Now, d squared, minus 2 times minus 2 will give you plus 4. Minus 1 times minus 1 will give you 1. 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is plus 4. Now, fd squared, begin to multiply the frequencies with the d squared. 6 times 4 will give you 24. 10 times 1 will give you 10. 24 times 0 will give you 0. 15 times 1 will give you 15. 6 times 4 will give you another 24. Now, by the time you add this fd FD squared together, what it will give you is the sum of FD squared. And it's going to give us 24 plus 10 is 34. Plus 15 will give you 49. 49 plus 24, 73. So we have 73 as the value of sum of FD squared. You're going to divide it by sum of F. Sum of F is the sum of the frequencies. 61. So let's divide out. Remember, whatever you have here, you will find the square root before you get your standard deviation. 73 divided by 61 is giving me 1.1967 in 4 decimal places. Now our SD, the standard deviation, is going to be the square root of that value, 1.1967. So let's find the square root. 1.1967 is giving us 1.0939, and that is the standard deviation for that distribution that the question has asked in part C. It is time for us to discuss about mean deviation. We have been discussing standard deviation in our previous text. Now it is time for us to discuss mean deviation. There is just a slight difference between standard deviation and mean deviation. You could recall that in our processes towards finding the standard deviation, whenever we get the deviation, there was always a process of squaring the deviations. The reason why the deviations were squared is to convert them or to make all the deviations a positive number. You could remember that some of the deviations that we had were negative. So in the process of finding standard deviation, we don't need negative deviations. That was the singular reason why all the deviations that we calculated were squared. And that is the only difference between standard deviation and mean deviation, because in mean deviation you don't square the deviations, but you will only assume that all negative deviations are positive. You ignore the negative nature of the deviations you will have as if they are positive. That is the difference between standard deviation and mean deviation. You square the deviations while finding your standard deviation, but you assume that the negative values you have among your deviations while finding your mean deviation are all positive. That means in finding your mean deviation in a distribution that has no frequency, you use this formula. MD is used as abbreviation for mean deviation, managing director. You find it by sum of x minus m divided by n. X minus m means number minus the mean, which you know is the deviation. So in this case, you don't square it. Divided by the number the distribution is. That is for distributions that have no frequencies. But for the one that has frequency, You calculate it by sum of FD divided by sum of F. This D, had it been it is a standard deviation, this D we have squared. And after all, that should be square root. But in mean deviation, just the sum of the product of frequencies and deviations divided by the sum of frequencies, no square root. That will give you your mean deviation. So I would like you to also memorize this formula, because we are going to be using it when we now go into solving problems that connects mean deviation. This is the first question we want to tackle in our discussion on mean deviations. We just said we should find the mean deviation of the distribution 72, 78, 72, 90, 72, 83, 79, representing the mass in kilogram of 7 teachers in a secondary school. Mean deviation. So the formula I told you we use in calculating mean deviation of a distribution that has no frequency, like this, is the sum of x minus m divided by n. X is the numbers, m is the mean, n is how many of the numbers are available, or how many of the number that is available in the distribution. So before we can apply this formula to find our MD, mean deviation, we must find mean first. And you know what mean is. Add together all these numbers and divide it by 1, 2, 3, 4, 5, 6, 7, which they are. So we first of all find our mean. We find our mean by 72 plus 78 plus 72 plus 90 plus 72 plus 83 plus 79, all divided by 7. 1, 2, 3, 4, 5, 6, 7 items. So use our calculator now. 72 plus 78 plus 79 is giving us 546. Then divided by 7. 78. So our mean is 78. Now that we have found the mean, we can go into applying our formula. That means our MD is now going to be calculated from, we are going to create a subsidiary table. X, the numbers, the mean, which we calculated. Then the next thing now is the deviation, which is x minus m. So let's have these values. So the x are the numbers. So bring in all these numbers here. So we have 72, 78, I'm copying these numbers. Another 72, 90, 72, 83, 79. So make it a table. Okay, then our mean, we calculated our mean to be 78. So write down 78 in all the columns under mean. They are the same thing in all the columns. Now our deviation, remember that this is deviation. X minus m. The numbers minus the mean will give you the deviation. So let's begin to subtract. 72 minus 78 give you minus 6. 78 minus 78 will give you 0. 72 minus 78 will give you another minus 6. 90 minus 78 is going to give you 12. 72 minus 78 is giving you minus 6. 83 minus 78 is giving you 5. 79 minus 78 is giving you 1. Now, our real deviation now, the real deviation we are going to apply in our mean deviation, as I told you, is assuming that all the negative deviations are positive. Real deviation, the real D. That means all the negative values you have here, call them positive. Ignore the negative nature of the negative deviations. Now, we are going to sum up this to give us sum of deviation. So that means our sum of x minus m is going to be 6 plus 6 is 12, plus 12, 24, 30, 36. So we have 36. Now the next thing we have now is our n. Our n is the number that is available. 1, 2, 3, 4, 5, 6, 7. So we have 7. That means our MD is now equal to 36 divided by 7. 5.1429 in 4 decimal places, kilograms. Remember, it is the distribution is the mass of teachers in kilograms in a particular school. This is question number 2. And this question says we should calculate the mean deviation of the age census conducted in a class, which is summarized in the table below, in this table. These are the ages: 14 years, 15, 16, 17, 18 years. And the frequencies are 1, 4, 2, 2, 1. We are asked to calculate the mean deviation. In all your processes to calculate standard or mean deviation, you must first of all calculate the mean. Because without the mean, you cannot calculate the deviation. Yes. So first of all, what we are going to do here now is to find our mean. And in our earlier stage, I told you that the formula for finding mean in a distribution that has frequency is our mean. We calculate from this formula the sum of the product of f frequency and the numbers divided by sum of frequency. This will give you the mean. So the first thing we are going to calculate now is the mean. The numbers are, we have to go down and construct a semi-subsidiary table to calculate our mean. So that table will take this shape. You have the x and you have the frequencies. Then you are going to have, maybe in the third column, fx. Now, The first number is, no, this cannot enter here. The space here is short. Unless we put it latitudinally. When you have X and you have F, it can only work latitudinally. That means horizontally. Okay? Let's put our X. The first is 14. The other one is 15. The other one is 16. The other one is 17. And the last one is 18. Then the next thing we might put here, if the space will permit us, is fx, the product of the numbers and their frequencies. Okay, the frequency here is 1, here is 4, here is 2, here is 2, and here is 1. Now our fx is 4 times 1 will give you, 14 times 1 will give you 14. Second one, 15 times 4 will give you 60. 16 times 2 will give you 32. 17 times 2. 2 times 7 is 14. 2 times 1 is 2 plus 1, 13. 18 times 1 will give you 18. Now, your sum of fx is, if you add all these numbers together, it's giving us 158. Now, the sum of our frequencies. 1 plus 4, 5, 7, 9, 10. So we have 10. Now our mean is summation fx all over sum of free frequencies. And it's going to give us 158 divided by 10. 158 divided by 10 is simply 15.8. And that is years. We are talking of the age of students. So this is our mean age, 15.8. So we are going to use this mean age now to calculate our mean deviation, our managing director, MD. I have told you, for a distribution that has frequencies, you calculate it by FD divided by sum of F. Sum of FD divided by sum of F. We are going to construct yet another subsidiary table where we have the numbers, their frequencies, then the deviation, the real deviation now, the deviation that we are going to apply. Then the next one is FD, frequency times deviation, which we have here. So let's divide this out. Okay, let's bring in the numbers 14, 15, 16, 17, 18. 14, 15, 16, 17, 18. So let's cross to make it a table. Okay. Now, the frequencies. The first one is 1. Second one is 4. Third one is 2. Fourth one is 2. And the last one is 1. Now the deviation. You know, we calculate the deviation from subtracting the mean from the numbers. So we don't have space to write them down, but what we're going to do now is all these numbers, we subtract the mean from them. Let's start from 14. 14 minus 15.8 is giving us minus 1.8. The next one is 15 minus 15.8 is giving us minus 0.8. Then the next one is 18 minus 10.8 is giving us 2.2. Now this is our deviations. So now let's take our real deviations. Assume that all the negative deviations are positive. So here we're going to have, instead of minus 1.8 plus 1.8, here we have 0.8. Bring down 0.2 is already a positive, 1.2 is already a positive, then 2.2. Now what we go into now is multiplying the real deviations with the frequencies. 1 times 1.8 will give you 1.8. 4 times 0.8, 4 times 8 will give you 32. So we are going to have 3.2. Now 2 times 0.2 will give you 0.4. 2 times 1.2 will give you 2.4. 1 times 2.2 will give you 2.2. Now let's go back to our formula. Summation FD means add up these values. Add up what you got as frequency times deviations. So our summation FD now is going to be equal to, let's add. It's giving me 10. Now our summation F. These are the frequencies. 1 plus 4 is 5, plus 2, 7, plus 2, 9, plus 1, 10. That means that our mean deviation, MD, is equal to 10 divided by 10, which is 1. So 1 year is the mean deviation of that distribution that is summarized in that table, which the question has asked us to calculate. Now this is question number 3, and it says that from the table below, we should calculate the mean deviation. In this case, we have class intervals. The previous ones we did, remember the first one we did has no frequency. Second one has frequency. This third one has class interval and frequency. So there are the 3 areas question can come to you when it is connected to mean deviation. The only thing that is unique in distributions that has class intervals in the process of finding the mean deviation is you will use the mid interval, the mid of the class intervals as your x. The middle of your class interval as your x. And what is the middle of your class interval? The middle of your class interval is just as you have 21 to 25. Add 21 and 25 and divide it by 2. The second one will be 23rd one, 31 plus 35 divided by 2. Fourth one, 36 plus 40 divided by 2. And the last one, 41 plus 44, 45 divided by 2. That is the mid-class interval. That is what you substitute for your x. And go ahead and calculate your mean as usual. Then use your mean to derive the deviations and calculate your mean deviation MD. So what we're going to do from here now is to create the subsidiary table. The subsidiary table will take this shape. We're going to have x. We're going to have f, that's the frequency. I'm going to have fx. So divide this into a tabular form. The x is going to be the midway of the class intervals. And how do you get them? 21 plus 25 divided by 2. In the first, you have 23. Second, 26 plus 30 divided by 2. 28. You are going to use them as x in calculation. The next is 31 plus 35 divided by 2. We have 33 here. The mid class. The next is 36 plus 40 divided by 2. We have 38. The last 41 plus 45 divided by 2. We have 43. So these are the values you are now going to use for x, because the distribution that is given to you are in class intervals. So the next thing we do now is we bring in the frequencies. Number of crates represent the frequencies. So the first we have 10, that's this one. The next we have 12, that's this one. 5, this one. 4, and then 2. Now we have to find our fx. Our fx means the multiplication or the product of x and f. In this case, 23 times 10 will give you 230. The next one, 28 times 12, 336. The next 33 times 5, 165. The next 38 times 4, 152. This will give you 86. Sum of all these fx, because we needed the sum of fx for our mean. So let's add them together. The first one is 230 plus 336 plus 165 plus 152 plus 86. It's giving me 969. 969. So that is our fx. Now you know that our mean is calculated by sum of fx all over sum of f. So the sum of our fx is now calculated to be 969. This one. Then we divide it by the sum of the frequencies. The sum of frequencies is 10 plus 12, that's 22, plus 5, 27, plus 4, 31, plus 2, 33. So we have 33 here, and whatever it gives us is our mean. Or let's place it here, see how space down here. So we have 969 divided by 33. Let's put it here. 29.36. And let's say 29.4 in one decimal place. That is the value of our mean. And that is the value we must be using in our calculation towards mean deviation, which is the main article that the question say we should calculate. Our mean deviation has the symbol MD, the managing director. Remember I told you that the formula for finding mean deviation is sum of FD divided by sum of F, assuming that the distribution has frequency, just as we have now. The distribution have frequency. Now we are going to open up yet another subsidiary table that will take this shape. Our X have to be there, our F will be there, then the mean that we calculated now will be there. After the mean, there will be column for the deviation, then the real deviation we are going to use. The real D will be there. After which, then FD, which we have here. So let's divide this out into a table. Our X, remember, are these values, the midway of the class intervals. So we have 23, 28, 33, 38, and the last one, 43. Our frequencies, the same order. We have 10, okay. The next is 12, we have 5, we have 4, and the last one we have 2. Now the next is the mean. The mean we calculated that we want to use is 29.4. So you have 29.4 in all the columns. 29.4 should be in all the columns. Now the deviation. Deviation is X minus M. So we're going to use our calculator and do it fast. 23, which is the X here, minus 29.4. Minus 6.4. The next is 28 minus 29.4. It's giving me minus 1.4. The last but not the least, 43 minus 29.4. It's giving me plus 13.6. This is our deviations. Now the real deviation we are going to use is ignoring the negative deviations. So instead of minus 6.4, we have plus 6.4 here. Instead of minus 1.4, we have plus 1.4. Then this is already in positive, already a positive, already a positive. Now our FD, we are going to multiply the frequencies and the real deviations. 6.4 times 10 will give you 64. The next is 12 times 1.4. 12 times 1.4. 16.8. The next is 2 times 13.6. 27.2. Okay, the The next thing we find out now is the sum of this FD, because that is what the formula is requiring of us. So we're going to add up this FD. It's giving me 160.4. Now, the sum of our frequencies, we have dealt with it before, is 33. Now, let's apply the values we have recovered now in our formula to get our MD. We are going to have here our summation FD is 160.4, while our summation F is 33. If we divide out, whatever we have is our mean deviation. So 160.4 divided by 33, giving me 4.86. And that is our mean deviation that the question has asked us for. And this has brought us to the end of our discussion on mean deviation.